In Unit 2 of the class, we start to think about the different processes of analysis that we do in GIS, specifically geoprocessing. But first, we'll take a look at the analysis process and ways that you can get your head around a topic that is quite complex and includes many different facets. This will help you develop a sense of how one goes about applying spatial analysis methods and basic scientific approaches to problem solving in GIS. First of all, in terms of analytical methodologies, this process follows a pretty common approach to defining problems and doing research within the sciences and social sciences. First of all, framing the question, and then understanding the data, choosing a method that will result in an analysis that's appropriate for your problem, calculating your statistics, that is doing the analysis, interpreting your results, and then testing the significance of your results, the statistic, and then questioning your results and analyzing your results. So the first basic questions are where to start, and then what is it going to take to reach the goal, how to proceed, when is it due if we're thinking about it in terms of classwork, and who is this for? One of the hardest things students grapple with is that they may have a good idea for a topic, but they really don't know how to get started. So we'll handle that part of the process first. So first of all, it's important to identify a problem. It's probably best for you to think about this in terms of a research question. What's the actual question you're trying to solve? The topic or the problem at hand might start out to be something rather vague. For example, if you wanted to do a project where you looked at the connection between two factors on the landscape. So for example, perhaps income and location relative to park facilities. There's been a lot of talk in recent years about how often impoverished communities lack access to green space. And as a result, people often find themselves living in places where they don't have access to the basic things that they need to be happy and healthy. So you might start out by asking the question, can you find a relationship between level of income or levels of poverty and access to parks? But you need to narrow that problem down pretty quickly so that you're defining it in terms of geographic location or region. You want to choose an area that's doable. You need to choose a problem then and define it in a way that again can be doable within the confines of the project you're looking at. Avoid the temptation to go chasing after too many shiny things. GIS is full of shiny things. Don't be the raccoon that's trying to go after the shiny objects when what he really needs to be doing is stripping your garden of its corn stalks in the middle of the night. You can be a raccoon and collect lots of shiny spoons, but that doesn't do the raccoon any good. There's a lot of fancy analysis you can do in GIS, but if you don't understand the data you're working with or the problem, then you're not really accomplishing anything very useful. So one of the most important things to do is have a good understanding about your topic and about the problem that you're interested in researching. And this often means bringing in much more ancillary and related information that gets way outside of the realm of GIS, but it gets into understanding the concept of what you're looking at and why it would be amenable to be studied with certain kinds of data and methods of analysis. So specify your problem and do it in a pretty specific way. Plan for your data and then understand the data that are available. One of the other things that students struggle with is that they often will find that they want to attack a problem, but the data they need in order to do it simply don't exist or can't be accessed in a practical way within the confines of a semester. So you need to design your problem around data that you can actually find, and then methods of analysis that make sense for the topic. Then you use you draw your own conclusions from the results, and you need to be able to analyze the information that you have then concluded. What's important there, again, is that you understand the topic at a general level, you understand your data, you understand the methods that you've used, and then that helps you make useful conclusions related to the outcome. One of the ways that you can look at doing this is to become familiar with the PPDAC model, which we'll take a look at now. First of all, the PPDAC model represents the first letters of the research process. We start with a problem, the first P. We plan, the second P. We collect data, we do analysis, and we draw conclusions. And with a problem, you need to then understand the dynamics of your case study, or your system dynamics if you want to think about it that way, and define your problem in a way that's measurable and doable within the confines of the project you're doing. Plan for your project with an awareness of what data are out there and available. Develop your a relevant measurement system and understand the data you're working with. And if you want to, you can do some trial and error piloting and analysis of the data to see how it acts and if it has the information you want in it. You need to take a good close look at the metadata as well when you're starting to think about how you will address a problem. The data collection, management, cleaning up process, you've been learning about that in Geography 1700 and now in 2700, and you'll continue to do that as you go through this course. You need to explore the data and understand what's there and see if your initial plan will actually result in the opportunities to draw useful conclusions. You can revise that plan then and go back to defining your problem in a way that may work better for you the second time around. This is why it's always a bad idea to leave these kinds of things at the last minute. And we have a pretty bloody history of students attempting to throw together projects at the last minute, and the results are definitely not pretty. So you do not want to fall into that kind of situation. After all, the fun in doing GIS is to bring your own data, your own ideas into the projects you're doing and your own thoughts and so on forward. And if you don't allow enough time to do that, you're not really taking advantage of the opportunities that you have. So first of all, how do we frame the question? So we start out with the question of what is the problem? And you need to understand why there's a problem. Sometimes people perceive there's a problem, and there might not actually really be a problem or not one that can be addressed within this course. Who's involved in the problem? Where is the problem? How do you define your case study? And why do you define it that way? And what's the time context that you need to look at? Is it something that's been a long-term issue? Is it something you're going to look at longitudinally, meaning over time? Or is it something that you would be limiting in terms of factors to just looking at one particular time, such as the current situation? And then planning, finding out what information is already available. So what's the data that's out there? For most of you, you won't be creating a lot of your own data for a project in a class like this. You may create some, though. And then you need to plan, how are you going to collect that data? And here's where having a plan and doing a log of your process, which is one of the tools that the class provides you with, and it's a requirement of your project, that doing that log is very important because it helps you keep track of the data that you're using. So you ask these questions about data collection. So how do we measure it? What are we measuring and how do we measure it? Sampling design. Do you have a sampling design? What units will take measurements and how will you do that? What's the data collection process? How will you manage the data? Now, for most of you in Geography 2700, you'll be grappling with the question of what to measure and how to measure it. Sampling design may be less important, but data collection and keeping track of your sources and understanding your data, very, very important, and then data management so that you don't end up with a mess of files at the end of the semester. If you look at your project assignment, you'll notice that it requires you to only include the data that's relevant to your study in your actual final copies of your project. In other words, you can't just create a bunch of analysis and throw it into a geodatabase and have it sit there. It needs to be there for a reason. It needs to relate to your study. So you'll have to clean your data up before you finish the whole thing. You then plan the analysis and report it, and you pilot and adjust. In other words, you try new things as you're going through to see if it's something, once you get into the data, that you can really work with. So data sources. We want to think about different options and different ways that we can look at the world, and the sources will entirely depend upon the case study that you're doing and the topic you're doing. And then data analysis. So methods of analysis, you'll be learning a great deal about analysis in this class, and that's very helpful because you'll become much more aware of some of the possibilities out there. Most of you, as you think about your projects, won't be doing the highest end, the most difficult analysis, the most complex analysis. You really need to limit your scope to things that will directly address the issues at hand. Just because you can do something that looks cool doesn't mean that that's what you should do for this project. And then when you draw conclusions, you'll need to think a little bit about the processes that, what's the meaning of the conclusions that you're pulling out of your data analysis. And do the data support your conclusions? Do the conclusions relate to the analysis? Do you actually have evidence that shows you that the conclusions are valid? And unfortunately, the way the world works is that we often do things in research and find out that our assumptions going into it were wrong, or maybe they were incomplete, or we just couldn't get the data or analyze it in the way we needed to draw those conclusions. That's why you want to allow plenty of time as you work on a project so that you can go back and recast it over time.